Assalamualaikum and hello everyone. Welcome back to our lesson on matrices. Let's continue with the next subtopic. Now, we will continue with subtopics 1.3, solving of systems of linear equation focused on matrix inversion method. In this subtopic, you will learn how to solve a system of equation using matrix operation, specifically by applying the matrix inversion method. Before we begin, please take a few minutes to complete a short induction activity. It is designed to help you to recall what you have learned in the previous subtopic and prepare you for this lesson. Learning outcomes. At the end of the subtopic, you should be able to solve system of linear equations up to 3 variables by using matrix inversion method. The matrix inversion method is usually used to solve system of equation with 2x2 or 3x3 matrices. These are square matrices with 2 or 3 rows and columns. Before we start solving for x and y using matrix inversion method, we must first find the determinant of the matrix. What is the determinant? The determinant helps us decide if a matrix can be inverted or not. If the determinant is 0, the matrix has no inverse. The determinant tells us if we can find the inverse of a matrix. Before we find the inverse of matrix, we need to calculate the determinant first. We can find the determinant for 2x2 matrix and 3x3 matrix. For the matrix 3x3, we have two methods to find the determinant. First row method. Second, diagonal method. Here is to find the determinant of 2x2 matrix, given that matrix A with the element A, B, C, D. Then, the determinant is calculated using the formula that A equals to A times D minus B times C. Example, show how to apply the determinant of a 2x2 matrix. Now, we move on 3x3 matrix. Let's start to find the determinant with the first method, which is called the first row method, also known as cofactor expansion method. In this method, we expand the determinant using the elements in the first row of the matrix. For each element, we remove its row and column to form a 2x2 minor. Then, find the determinant of that 2x2 minor. We also apply alternating sign plus, minus, and plus across the first row. For the first row and second column of matrix A, that are B, becomes its coefficient, and don't forget to put negative sign for the second column. So the full expansion becomes that A equals to A in bracket EI minus FH minus B in bracket DI minus FG plus C in bracket DH minus EG. This method is useful for learning how to find minors, cofactors, and for calculating the inverse of 3x3 matrix. This example shows how to apply the first row method to find the determinant of a 3x3 matrix. The diagonal method, also known as the Sarus method, is a shortcut used to find the determinant of a 3x3 matrix. This method is simple and visual, and it only works for 3x3 matrix. To use this method, copy the first two columns of the matrix beside it. Then multiply the numbers along the diagonal from top left to bottom right and add them up. Next, Do the same for the diagonal from bottom left to top right and add them too. Finally, subtract the second total from the first and that's your determinant. This example, how the diagonal method is used to find the determinant of a 3 by 3 matrix. Matrix inversion method can be used for both 2 by 2 and 3 by 3 matrices. For a 2 by 2 matrix, the steps are simple and use a direct formula. But for a 3 by 3 matrix, the process is longer and needs more steps like finding cofactor and the adjoint. To use this method, first we write the system in a matrix form AX equals to B, where A is the coefficient of matrix, X is the unknown of matrix like X, Y, and Z, and B is the constant of the matrix, that is the value on the right hand side of the equation. Once we have this form, we solve for X by multiplying the inverse of A with B, using the formula X equals to A inverse B. This means we are reversing the effects of matrix A to find the value of the unknowns. However, this method only works if matrix A is a square matrix and its inverse exists. If these conditions are met, the matrix inversion method is a fast and reliable way to find the solution. Now, let's look at how to find the inverse of a 2 by 2 matrix. Don't worry, it's actually quite simple. Suppose we have a matrix A that looks like this. A with the element A, B, C, D. Step 1, we find the determinant using the formula that A equals to AD minus BC. If the determinant is 0, that means the matrix has no inverse, and we stop there. But if the determinant is not 0, we can continue the step. Next step is we need to arrange the matrix like this. Swap the position of A and D, then change the sign of B and C to be negative B and negative C. So we can get D, negative B, negative C, A. Step 3, we multiply the whole matrix by 1 over determinant, just like the formula given. That's the inverse of a 2 by 2 matrix. To find the value of X and Y, we express the system in matrix form AX equals to B. Then we apply the inverse matrix formula. To do this, we first find the inverse of matrix A using the formula. Once we have the inverse, we multiply it with matrix B to get the final value of X and Y. This method provides a clear and systematic way to solve a pair of linear equations using matrices. This is a summary of how to solve a 2 by 2 matrix equation to find X and Y using matrix inversion method. A step-by-step guide to solve for X and Y using matrix inversion method. Now, let's look at how to find the inverse of a 3 by 3 matrix. It takes more steps, but we will go through it one by one. Let A be a 3 by 3 matrix with the element A, B, C, D, E, F, G, H, I. Step 1, you need to find the determinant of A. Step 2, find the matrix of minus. For each element in the matrix, we find the 2 by 2 determinant of the remaining number after removing the elements row and column. Then, step 3, turn it into a matrix of cofactor. To form the cofactor matrix, take each minor and add the correct sign using a plus-minus pattern like a checkerbox. Start with a plus in the top left, multiply each minor by its sign. This gives the cofactor for that position. Then, step 4, find the adjoint. Adjoint is the transpose matrix of cofactor. Swap rows and columns. For the step 5, divide the determinant. Now, take the adjoint matrix and divide every number in it by the determinant of the original matrix. This gives you the inverse matrix. Make sure the determinant is not 0. If it is, the matrix has no inverse. Now, let's solve for x, y, and z by using the matrix inversion method. First, we need to write the system of equation in matrix form AX equals to B. Then, we find the inverse of a matrix as long as the determinant is not 0. Once we have the inverse, we multiply it by matrix B to get x. The resulting matrix gives us the value of x, y, and z. This is a summary of how to solve a 3x3 matrix equation to find x, y, and z by using the matrix inversion method. We will go through it step by step, starting with writing the equation in matrix form, then find the determinant of the matrix. Now, we are going to find the cofactor of matrix. This is done by finding the minor of each element and applying the appropriate sign based on the plus-minus checkerbox pattern. Each cofactor is just the minor multiplied by its sign, and this gives us the cofactor matrix. Then, we transpose the cofactor to get the adjoint. After that, we substitute the value that we have in the formula to find the value of x, y, and z. This will give us the value of x, y, and z clearly at the end. That's the end of subtopic 1.3 focusing on matrix inversion method. Good job! Next, we will continue with subtopic 1.3 on solving linear equation using Cramer's rule method. Don't forget to finish the exercise and quiz before moving on. Good job!